So the title of the talk today is ScyllaDB and Kafka. We're going to talk about streaming data in real time. My name is Guy Shtub. Like I said, I'm based in Israel. I'm a software engineer. I'm head of training at ScyllaDB, and I've been with the company for almost 7 years, so quite a while. At least in the IT world, that's a long time. I have the talk today is live, so it's not recorded. I'm looking at the slides on one screen, but I also have the chat window open in the other screen. So if you have questions or if I'm going too fast or too slow, let me know. We have a different audience that comes to these talks, and yeah, I would like to sort of tailor the talk to the audience that's actually here. Okay, great. So here is what I planned to talk about today. I will start with an intro to ScyllaDB. What is ScyllaDB and why should you care about it? Then I will talk about Apache Kafka, provide an overview of Kafka. Just very high level, I won't go into details. And then I will talk about two ways to work with Kafka and ScyllaDB. One is using the sync connector, and one is using the CDC source connector. Both are open source projects, by the way, as is Apache Kafka is also open source. And I will also talk about CDC, which is change data capture. And that's a feature of ScyllaDB that's very closely related to Kafka and to the topic that we're talking about today. I don't think that I'll have time to show you actual demos, but I will provide links to demos that you can run. The slides that I'm showing you today will be available to you. So we will share a link with the slides with you after the talk, probably by email. And I will also send you an email with links for more information. Okay, great. Please, if you're just joining, mute yourself so the other people can't hear you. Before I get started, two very useful resources. One is ScyllaDB University. That's at university.scylladb.com. And I'll show you some examples from ScyllaDB University, but those examples are available to you and you can run them at your own time, at your own pace, sorry. Scylla University has many lessons on different NoSQL topics, including the integration between Kafka and ScyllaDB. It has videos, slides, quizzes, labs, lots of useful content, and it's completely free. To get started with it, you just create a user and you can start learning. So that's one useful resource. The second one is our documentation website, and that goes in more depth into procedures, different flags or arguments for command lines, for the command line interface, for other procedures. So that's also useful if you're playing around with the software. Yeah, another thing is that we have training events every once in a while, every few weeks, I would say. And the next one is happening next week on Thursday, I believe, May 14th. It's called ScyllaDB Labs, and we're going to be talking about building high-performance apps. The event is online and it's free, and you can register on this link. Let me maybe... Well, I'll send you the link later on. Okay, so let me get started with what is ScyllaDB. Yeah, just so I know the level of the people that are listening to this talk, if everyone can quickly write in the chat window if this is the first time you hear about ScyllaDB, or if maybe you already are using ScyllaDB. Like, what's your experience regarding ScyllaDB and regarding NoSQL in general? Like, are you a user? Are you new to NoSQL? If you can just take a minute to write that in the chat window, I'll also get a feeling that I'm not talking to myself, which would be nice. So my question is, have you used ScyllaDB before? Are you new to it? And if you're new to ScyllaDB, do you have experience in other NoSQL databases? Let's wait another few moments for people to answer. And thank you to the people that answered, Joseph, Sergey, and apologies in advance if I mispronounce names. Okay, so I see that the people that answered are experienced in NoSQL. Some have used ScyllaDB, even together with Kafka, but some are new to ScyllaDB, and some are completely new. Okay, I appreciate the answers. Thank you. So since many of you are new to ScyllaDB, I'll talk about the database in general and where it fits in the NoSQL world. Maybe before that, the CAP theorem, availability versus consistency. So that's just to get an idea where we are. As you probably know, there are dozens of database solutions out there. Each one has its advantages and disadvantages depending on your use case. So this is one way to look at it. The CAP theorem talks about the trade-offs between consistency, partition tolerance, and availability in distributed systems in general. And specifically, we talk about distributed databases. And the theorem states that there's a trade-off. We have to give preference to 2 out of the 3 attributes here. Consistency, of course, talks about every read receiving the latest write. Availability means that our system will be up and running and serving requests at all time. And partition tolerance talks about what happens when there's a network failure and nodes cannot communicate with each other in a distributed system. So I put some logos here of some different databases. It's just, of course, just a few of the databases. But just to give you an idea, some databases like Cockroach Labs or Mongo give a preference to consistency over availability, whereas Apache Cassandra, ScyllaDB over here, and Amazon DynamoDB give a preference to availability over consistency, okay? That doesn't mean that those databases are not consistent. They provide something called eventual consistency, which is a whole different topic. I can do another complete talk just on that, but that's a bit out of scope. I'll just say that they do provide consistency, but they give a preference to availability over consistency. An extension of this theorem is called Paselk theorem, which talks about, it's sort of an extension of the previous theorem that we saw, and it talks about what happens when there is a network partition. So if there is a network partition, we go back to the previous slide and we have to choose between availability and consistency. However, if there's no network partition, if the network is working as expected, then there's another trade-off that we have to consider, and that one is between latency and consistency. Okay, so that makes sense. In distributed systems, typically data is replicated, and I might talk about that just a bit. When data is replicated, it goes together with high availability because we have multiple copies of each piece of data, avoiding any single point of failure. But on the other hand, having more writes and possibly more reads can have an impact on the latency, right? So there's a trade-off between latency and consistency when there's no partition in the network. Okay, another way to look at it is if we look at NoSQL databases, according to the data model. And I classified it here quite maybe in a simple manner into 4 different types of data model, going from the most simple to the most complex. And again, wrote a few examples of each type of data model. So I'll start with a key value data model. Just as simple as it sounds, we have a key and the value, nothing complex in terms of tables or schemas. Examples of these databases, RocksDB and Redis. Going into a bit more complex data model would be document store databases, and there you can store the data in pre-formatted documents. Think about XML or JSON or others. And examples here are MongoDB and Couchbase, and of course there are many more. The focus today is on wide column databases. And in this family, I chose as examples ScyllaDB, Apache Cassandra, which is a popular database, and Amazon DynamoDB, which is also quite a popular database. And here we can think, sometimes it's also called key value data stores, but we can think of the data as rows and columns as you would expect in relational databases. So it's a bit more complex. And finally, we have maybe the most complex data model, and that would be graph databases. And here I chose 2 examples. There are more. One is Neo4j, which is a popular one. Another is Janus Graph. And in these databases, data is modeled as edges and vertices. Okay. Usually that's used with geographical or spatial data, mapping, stuff of that sort. And just as a side note, Janus Graph can work with ScyllaDB as the underlying data store. Okay, so I talked about NoSQL in general, a few words about ScyllaDB. ScyllaDB is a distributed real-time big data high-performance database. And it's used by quite a few users. I put some examples in this slide, but there are many more, and there are probably names that you're familiar with. I don't know, Expedia, Zillow, Electronic Arts, and some others. I wouldn't say that we have one specific industry where we get most of our usage from. There are different industries and different use cases. And if you're wondering about your specific industry or use case, you can just have a look at our website, and you can look at different industries and see examples from your specific industry to see what other people are doing. There is a question if the recording will be available, and Vered, correct me if I'm wrong, but I'm pretty sure the recording will be available, and we will share a link with you. So you will get an email with a copy of the slides, links to the labs that I'm talking about, and also the recording of the video. Okay, so ScyllaDB, the company started about 10 years ago. The database was written from scratch in C++, very close to the hardware, with performance in mind. Some of the attributes of ScyllaDB are high availability. So it's a distributed system. In a typical cluster, we have between 3 nodes to hundreds of nodes running together to provide service. Like I said, no single point of failure. So even if a single node goes down, there's a network failure, or even if an entire data center goes down, which is unlikely but can happen, the system is built in a way that it would still provide service. The system is highly scalable, and that means that it's easy to add or remove nodes to scale the system up or down. So it's very elastic. And that can be done without any downtime. Okay, so maybe just an example to demonstrate what I mean. Say we're running some kind of e-commerce website shop, and we're using ScyllaDB as the underlying data store, and we know that Black Friday is coming up. We're going to get more traffic. Say that right now we're running ScyllaDB on 5 nodes. So maybe a week before Black Friday, we can add 2 or 3 more nodes. When we do that, there's no downtime. The data will automatically be redistributed across all the cluster to the new nodes. When Black Friday arrives, our application will be able to serve more requests as there are more nodes. And maybe after Black Friday, if we see the traffic goes down, we can remove those nodes. Okay, so it's very highly scalable, and that happens very, very fast. The system is performant. That means high throughput. And when I say high throughput, I'm talking about hundreds of thousands or even millions of operations per second, and very low latency. And when I say low latency, I mean that we have queries performing at single-digit milliseconds, so that's very fast. And that's not only an average, very importantly, it's the P99 latency, which means that even the worst 1% of queries still performs very fast. Sometimes other databases talk about the average latency, and that can be misleading. If we talk about databases that use languages like Java or are written in Java, and then we have garbage collection happening every, say, few hours, we would see a latency spike. And the average still might be quite fast, but that latency spike translates to a bad experience for the users as their user interface becomes unresponsive or the system is not providing them service. So with ScyllaDB, the P99 latency is very fast. Low maintenance, different auto-tuning capabilities, the fact that we don't have garbage collection. I won't get into that. And also, we're a drop-in replacement for Apache Cassandra and for Amazon DynamoDB. And that means that if you're currently using one of those databases, you can replace the data store with ScyllaDB, pretty much keep your application as it is. We offer 2 products, basically. One is ScyllaDB Enterprise, which allows you to run ScyllaDB on-prem, on your own servers, or on any cloud. You deploy it as you wish. And the second offering is ScyllaDB Cloud, which is our database as a service offering. It's more popular. We see more and more users choosing this option. And just like it sounds, you get ScyllaDB as a service. We take care of things like backup, restore, security hardening, upgrades, repairs, all of those administration tasks that you don't have to worry about, so you can focus on building your app. What else do I want to say about that? With ScyllaDB Cloud, you can run on different cloud platforms. So it works with AWS, with GCP, and with others. And also, one of the reasons we see users choosing ScyllaDB is to avoid vendor lock-in, okay? So ScyllaDB runs on multiple clouds, and you don't get a lock-in with a specific cloud, like AWS or others. Okay, why ScyllaDB? I think I talked about most of these things, but you get predictable performance at scale. So I talked about price to performance, high availability, disaster recovery. I have a slide on that. I talked about scalability, auto-tuning, no lock-in. So yeah, I think I pretty much covered all of the things in this slide. Yeah, and same here. I could talk quite a lot about the architecture of ScyllaDB and how it provides such a fast performance. But again, that's a bit out of scale, and I want to have some time to talk about Kafka and the integration with Kafka. So yeah, maybe if that's interesting to you, you can have a look on ScyllaDB University. at architecture, or you can send me an email, and I can arrange for the next talk to focus on that topic if it's interesting for people here. Okay, I mentioned high availability and multi-data center. So I didn't really talk about that. ScyllaDB is built to be topology aware, and it can run on multiple data centers. Okay, so the database knows about the topology of the deployment. It knows about different data centers on which it is running, and it also knows even about the racks within each data center, okay? So here we have an example of an application using 3 data centers. Say one is in the United States, one is in Asia, and one, say, in Africa. There are different advantages for using multiple data centers. Does anyone have any idea why we would want to use multiple data centers? If you could quickly write that in the chat window. What are the benefits of using multiple data centers instead of just using one data center? Does anyone have any idea? If you can write that in the chat window. So one answer is it's nearer to the user, nearest to the user. That's correct. High availability, partition tolerance, availability, latency, resilience, scaling, low latency. Any other ideas? There's one more important reason that nobody wrote. Disaster recovery, cost. Okay, so those are all correct. There are a few more. And there was a comment by Teddy, I believe, that it looks like Cassandra. And that's a good point. So originally, 10 years ago, ScyllaDB was inspired by Apache Cassandra. That's sort of how it started, even though I don't believe that we have any code that's used by Cassandra. It was written from scratch, but it does have a shared history with Cassandra, and by the way, also a shared history with DynamoDB. There was an influential paper written, I don't know, like 20 years ago, that inspired different databases in this key value data model storage type. Okay, so let me talk a bit about multiple data centers. So you mentioned latency, and that's correct. It would make much more sense to serve a user, say, from the United States, from the data center in the US, just because it takes some time from data to travel from, say, Asia to the US, because of physics. We can't change the laws of physics, so it would just be faster to serve requests from the nearest data center, and then maybe asynchronously sync between the different data centers. So that's one reason. Another reason that was mentioned here is disaster recovery, which is kind of similar to high availability. And even in the unlikely case that an entire data center goes down or a rack within a data center goes down, the other data centers can still serve requests, right? So it creates an additional point of redundancy, and again, no single point of failure. Another reason that we see more often, exactly, I see that Gary wrote that, is data sovereignty. So in some jurisdictions, some countries or jurisdictions, there are rules or laws that require that data of users remain in that specific geographical area. Okay, so for example, we can configure the system to work in a way where all the data of people, say, of users in Europe remains within the EU and doesn't leave that jurisdiction. Okay, so that's also a common reason to do that. Here we have an example. I don't remember when this happened, but this is fire, a disaster that happened in a cloud provider. I think it was in France, in Europe. If I'm not mistaken, the name of the cloud provider was OSH Cloud or OVH Cloud, something like that. And there was a big outage, millions of websites went down. One of our users, a company called Kiwi, also suffered from that data center going down. However, because they were using multiple data centers, they did not have any downtime, and their users could still get the service they expected, as other data centers had nodes of ScyllaDB and they could serve requests. Okay, so it is unlikely, but it can happen. And if you Google it, I think they wrote a blog post about it as well. Okay, maybe the last slide before I go over to talk about Kafka and the integration. So we get a lot of users that migrate from different databases to ScyllaDB. I put some examples here. I don't really want to go into the detail. Maybe I'll just choose one. So we had one user migrate from Apache Cassandra to ScyllaDB. They were running 40 nodes of Cassandra, and they replaced them with 4 ScyllaDB nodes. And not only did they have less nodes, which translates to easier maintenance, of course, they also got a solution that was 2.5 times cheaper, and they got 11 times better P99 latencies. Okay, so they got a way better solution for a lower cost with less nodes just by replacing Cassandra with ScyllaDB. And you don't have to take my word for it. You can see the exact benchmarks on our website comparing migration stories from different databases. Okay, what you're seeing here in this slide is our monitoring dashboard. So if you are ever running ScyllaDB in production, by all means, install the monitoring stack. It uses Grafana and Prometheus, open source projects, to allow you to see what's happening in your cluster. And in this example, we're seeing a 3-node cluster running on I4I 8x large on AWS and serving 1.1 million requests per second with latencies that are lower than 1 millisecond for the P99 latency. So quite impressive. And again, you can run this on your own. It's on GitHub. You can see this link, and I'll also share that with you afterwards. So you can play around with it and run it on your own. And you can also play around with ScyllaDB Cloud. You can create a user on ScyllaDB Cloud, and with a few clicks, start a cluster with a free demo. There's a question on the chat window about latencies that are distributed over continents. So how do we guarantee single atomic writes? Not sure if I understand the question, but I'll try to answer it anyway. So ScyllaDB, as well as Apache Cassandra or DynamoDB or other NoSQL databases, don't provide ACID guarantees. So writes are not necessarily single/atomic, okay? So there is something called eventual consistency. And again, I don't want to get into it, but basically that means that you as the user of the database, you can define the required consistency. There's also something called lightweight transactions, which provides higher consistency levels. And there are special column types, such as counters, which do provide a guarantee of atomic writes. Okay, so if I have to summarize it, it depends and it's complicated, but it's definitely not as simple as relational databases where you have those guarantees. But of course, there's a trade-off here, and unlike relational databases, you don't have the guarantee for consistency, but you have many other benefits, namely the high availability and the high performance. Okay, so I put a link here to a quick wins lab. I'm not going to run it right now just because of the time, but let me show you the lab anyway. So what you're seeing here is the ScyllaDB University website. Okay, this is a browser, it's just full screen. And the university website, once you create a user, you can see different courses. Why is this not working? So we have 6 different courses, and the first one for beginners is ScyllaDB Essentials. And if I click on that course, I can see the Quick Wins Lab. And this lab just helps me get up and running with ScyllaDB. So we use a platform that actually allows us to run the lab within the browser. Okay, let me launch it. And I hope that you can see it. Let me maximize the window. So what this does actually is it starts a virtual machine within the browser, and then I can play around with creating a cluster. So for example, this command starts a single node ScyllaDB cluster with Docker, and then I can connect to that node, and I can perform some reads and writes and play around with the database. Okay, so that makes it easy because we don't need to install anything basically. We just copy and paste these commands, and we can play around with the database. So I'm not going to do that right now just because I want to talk about other stuff. But like I said, you'll get the link to that and you can play around with it yourself. All right, let me go back to the slides. Okay, so that was the Quick Wins Lab, and I already asked you this question. Let's talk a bit about Apache Kafka. So Apache Kafka is an open source solution. It's a distributed event streaming system, and it's very widely used. It's used by many companies. It allows users to basically ingest data from different systems, like databases or other microservices. It can store that data or perform some processing on that data. And it can also allow other systems to consume that data. Okay, so it basically provides streams in real time. It's quite flexible, and I believe it was initially written by LinkedIn and open sourced around 15 years ago, something like that. Some common use cases for Kafka as a message broker, similar to other solutions, as a glue between different services in your system, to replicate data between databases or services, or to perform real-time analysis of your data for things like fraud detection and other many use cases. There are different distributions of Kafka. There's the open source version, Apache Kafka. There's Confluent, which is an enterprise-grade distribution of Apache Kafka, a commercial one. And that one has additional features. So it's based on the open source version, but it provides more features. They also provide it as Confluent Cloud, which is as a service. The example that we have on ScyllaDB University uses the Confluent platform, okay, just because they have a web interface and it's easy to get started. So you can play around with that. I'll show you the link later on. Additionally, there is a company called Red Panda, and they are Kafka API compatible. And they claim to provide much faster performance than regular Kafka or Confluent. And as a side note, just a curiosity, underlying Red Panda is something called the C-Star framework, which is also used for ScyllaDB. It's an open source framework for sharding and using shard per cores and for writing high performance applications, which is also open source, by the way. So a high-level overview of what happens with Kafka. So we have the system, and then we have producers that can, using different source connectors, produce data that's written into Kafka. Kafka can then do some processing with that data. And there are different consumers which, using sync connectors, consume that data and do different things with it. So it's very generic. There are many different things you can do with it. And today I'll talk about how ScyllaDB connects with Kafka. Kafka also works in a distributed manner. There are nodes, which in Kafka are called brokers, and you can have multiple nodes. That also goes together with performance and availability. And there are also different partitions, which provides in Kafka a method to reduce the to actually separate different workloads and to make them work in parallel. And it uses a Kafka message typically has a key value and a header. These are some examples, a key and a value. Here it's the partition key and the clustering key, and it can also be other data. And that data, as you can see here, is typically formatted. Here it's JSON, but it can be other document types depending on the format that we choose. So how does that work with ScyllaDB? I'll go into more details, but basically we have two types of connectors. One is the source connector, which provides data from ScyllaDB to the Kafka server, and that uses, the slides are not updating. So now you're supposed to see a source connector slide. Let me go forward and back. Are they updating now? The title of the slide should be source connector. I hope you're seeing what I'm seeing. If somebody can just confirm in the chat, which slide are you seeing now? They're okay? Okay, thanks for letting me know. Let me know if the slides are out of sync. Okay, so sorry about that. So we have the Scylla source connector, which, by the way, is an open source project, and that reads data from ScyllaDB and pushes it into the Kafka server. And it uses something that's called a CDC table. CDC is change data capture, and I'll talk about it in just a bit. From Kafka, we can read data using the ScyllaDB sync connector and push that back into the database. Okay, so it's possible to push data from ScyllaDB to Kafka and also to consume data from Kafka into ScyllaDB. So I put a link here to another demo. Again, I'm not really going to have time to show you the demo itself, but it's very easy to run it. Maybe let me just show you how it looks like on Scylla University website. So if you take a look at the course called Mutant Monitoring System and Integrations, that's sort of like a course that we have which talks about integrations between ScyllaDB and different other systems. And then you have a lesson called Kafka and ScyllaDB, and it has 9 different topics covering an overview and different components. By the way, each one of these is a video with slides, which you can watch. And then the last one here is a lab where you can run the source connector with Kafka on your own. It uses Confluent. And this one doesn't use the Instruct platform that I showed you before, but you do have simple commands that use Docker and the GitHub project that you can run by just copying these commands, and running them on your machine or on any virtual machine. Okay, so this spins up a cluster and using the web interface of Confluent, you create the connector and see how it works. Okay? So I highly recommend you check that out. Let me go back to my slides. Okay. So the way the demo works is you're going to use the Confluent platform, start a local development deployment, create a topic. You're going to write to the topic using the web interface, and then read from that topic and see how that connects to ScyllaDB. And let's talk about the sync connector. So the sync connector, well, there are dozens or even hundreds of different connectors for Kafka. It's a popular platform. And Scylla is just one of those connectors. I mentioned it's an open source project. And it allows us to read messages from a Kafka topic and insert them into the ScyllaDB database. It supports different formats. Popular ones are probably the most popular is JSON. And it can work across many Kafka nodes. Okay, so it scales. And it has at least one semantics, meaning that even if there is a failure, it's configured to start again from where it last failed or from the last offset. And here's an example of the sync connector. So we have a message coming in from Kafka. The connector would translate that into data that ScyllaDB can insert into a table that was created in advance, and it simply inserts those messages into the Scylla table. Okay, let's look at the other way around. So moving data from ScyllaDB to Kafka, which is a common use case, and that uses something called CDC. And let me talk about CDC in just a few words. So CDC is a feature called change data capture, and that allows users to track changes or updates to the data that they have in the system. So basically the way that it works under the hood is that we create a table and we define if we want to have CDC enabled. What ScyllaDB does under the hood is it creates an additional table, and then for every change that happens to the base table, it writes in the CDC table what that change was. So if, for example, we say write something to the base table and then update that row, in the base table, we're only going to see the updated row, right? So we're going to see the latest value. However, in the CDC table, we're going to see the first write, and then we're also going to have a row that says that row was changed and when it happened. Okay, that can be very useful for many different use cases, things like analytics, fraud detection, different use cases. Maybe I'll touch on a few a bit later. But that's in essence what change data capture does, and it's defined either per table or per row within the table. There is an entire lesson on Scylla University about CDC, how to use it, how to define it, common pitfalls, things you should be careful about. So yeah, you can have a look at that as well. Maybe I'll just mention one thing is that if you're using CDC, keep in mind that the amount of data that you have can grow very fast, right? Because for each operation that you're doing, you're creating additional writes to an additional table. So keep that in mind. And when you create your data model and create your tables, consider using features like TTL, which is time to live, which automatically deletes data after a certain time period that you define. Okay, just to avoid a case where you have more data than you can you basically have space for. Okay, so the source connector is based on CDC. It's also an open source project. And what the CDC source connector does is it reads messages from a ScyllaDB table with CDC enabled, and it writes that data into a Kafka topic. Okay, it works with converters, again, in different formats like JSON, and it can also scale. And just like the sync connector, it also has at least one semantics. And this is what we previously saw. And this is kind of similar, just that instead of reading the data from Kafka into ScyllaDB, Scylla is the one that's producing the data, and Kafka is the one that's sort of consuming the data, but that's getting the data from ScyllaDB. Okay, and you can see here in this example, we have the table, which is defined as source topic 1. We define the 3 columns with the data types in the table. We define the primary key, which has a partition key and a clustering key. And what makes CDC work is we add the with CDC enabled, which under the hood would create an additional table, which would be the CDC table for source topic 1. Okay? No, so I don't understand why you're not seeing the correct slide. So now the slide you should be seeing is Scylla CDC course source connector demo. Sorry about that. So I hope that now you can see the right slide. It's Scylla CDC source connector demo. Maybe if I move the mouse, it refreshes it. Okay, sorry about that. Okay, so this is an example of CDC setup. Again, this is just one example out of many different examples that I could have come up with or that users are using. So here we have a ScyllaDB cluster. A user is doing something with a cluster, say writing data. CDC is enabled, so the data is also written to the change data capture table. Using the CDC source connector, that data is then transferred into Kafka or Confluent or Red Panda for that matter, whatever you choose as the user. And then the consumers, meanwhile, can do different things with that data. Okay, so it separates the systems and allows ScyllaDB to continue working in the background. And then we can do things like text search, say with Elasticsearch. We can run different analytics, say fraud detection, or other things that we can do to analyze the data or do some kind of processing on the data without this having any impact on the ScyllaDB cluster and the workloads that's being performed by the database. Okay, things like data lakes, real-time analysis with Spark, which is another topic that we can talk about out of scope for this talk. And then, by the way, after we do this analysis, we can also write data back to the cluster. Okay, so there is a question, is CDC available in the ScyllaDB open source version or is it a paid feature? Wow, yeah, that's a good question. I don't remember. I'm actually not sure. You can quickly Google it. I don't want to give you a wrong answer. I will say that ScyllaDB used to be open source, and recently, like a few months ago, it changed, and now there's still an open source version, but now ScyllaDB became source available. Okay, so the license changed. What we did is we had 2 basically separate products. We had ScyllaDB open source, and then we had ScyllaDB Enterprise. And it was quite a pain to maintain those 2 product lines. So we merged them into one product, which is ScyllaDB Enterprise. ScyllaDB open source is still available. The last version, I think, is 6.2. But if you're new to ScyllaDB, I recommend you use the enterprise version. And it's also source available, and there's also a way that if you're using it, I believe, with less than 10 terabytes, then you can use it for free. So check that out. And the open source version, you can use it forever. However, at some point, it would be a better idea to move to the enterprise version just because it's not being supported anymore. And all the new features, bug fixes, and so on are going to be in the new versions. Okay. And then, of course, if you use the enterprise version, whether you're a paying customer or using Scylla Cloud or using the under 10 terabyte program, then you can definitely use CDC. Okay, so we have some use cases. I just chose like 2 or 3 use cases from some of our users. This is a company called Responsive, and one of their co-founders in the last Monster Scale Summit, which took place just a few months ago, he gave a talk about how they replaced RocksDB with ScyllaDB and Kafka streams. So again, that's a big talk, and you can see what they did and maybe learn from their experience if that's relevant for you. Another example is from Numberly. If I remember correctly, Numberly are using ScyllaDB together with Kafka for fraud detection. So cybersecurity, that's their use case. And I put a link here to a blog post. I think there's also a webinar somewhere about what they did from Alexis, which is, I don't remember his position, but one of the employees at Numberly, and he's also contributing code to different open source ScyllaDB projects. And then there's another example with ShareChat. ShareChat is a big social platform in India. It's quite a big company. And they talked about how they're using Kafka streams with ScyllaDB. And you can also see that talk. I put a link right here. A few more useful links. So this is the link to the GitHub open source project for the ScyllaDB sync connector. I also put one for the CDC source connector. You can see the code. You can send a patch if that's your thing. You can compile it and play around with it. Of course, you don't need to go to GitHub if you just want to use it. It's also available through Confluent or by other means of downloading it. I put a link to the university lesson for Kafka. Lots of useful material on Scylla University, so check that out. I also put a link here to the community forum. So we have a community forum where you can ask questions. Our engineers and experts hang out there. You can ask them questions. You could just say how you're using ScyllaDB, see how other people in the community are using ScyllaDB. So check that out, and you can download Scylla and play around with it. That's it from me. Stay in touch. This is my email. By the way, HR asked me to mention that we're hiring. So if you're looking for a job, look at our careers page. You can also send me an email with your CV. And if you have a use case and you think it might be a good fit for ScyllaDB, my recommendation is that you get in touch with us. We have field engineers with a lot of experience, and they will be able to tell you quite fast if it's a good use case for ScyllaDB. Maybe it's an overkill and you're better off using some other database. So get in touch, ask questions, say hello, and yeah, that's it pretty much for me. Maybe we have time for one question, if there are any. And if not, I will say again that you will get a message, an email. I will share the slides with you. You will also have a link to the recording and to the different links to the labs, to the projects that I showed you. And that's it. Thank you for joining. I hope you learned something. Bye for now.